Welcome to the lesson Weather Radar. Weather radar utilizes microwave signals to detect precipitation ahead of the aircraft by measuring the time delay and intensity of the reflected radiation. The system is also capable of turbulence detection and ground mapping. Weather radar information is displayed on a weather radar display on the center console, and can also be repeated on the EFIS navigation displays. A transceiver behind the radome transmits and receives microwave pulses at a frequency of 9.345 GHz through a 24-inch flat plate antenna. Click on an element to view a photo. The wavelength of 3.2 centimeters is optimized to efficiently reflect large water droplets. Small cloud droplets will not be effectively detected. Weather detection is available up to 320 nautical miles ahead of the aircraft. A turbulence mode is provided, which detects the Doppler shift of the received pulses as they are reflected off water droplets having a horizontal velocity component. The system is not capable of detecting clear air turbulence. To provide large area cover, the antenna scans in azimuth through 80 degrees left and right of the aircraft centerline. The antenna is automatically stabilized with reference to the horizon by IRS number 1, with a mechanical limit of plus-minus 15 degrees in pitch and plus-minus 30 degrees in roll relative to the aircraft axis. Following failure of IRS number 1, stabilization is transferred to IRS number 2 using the attitude heading switch. The antenna can be manually tilted either 15 degrees above or below the horizon within the mechanical limits. In our example, the aircraft is pitched 10 degrees up. This reduces the tilt down ability to 5 degrees, whereas 15 degrees tilt up are still available. Remember, tilt angles are relative to the horizon, whereas the mechanical limits are relative to the longitudinal aircraft axes. The display unit is comprised of a display and an integrated control panel. Now, let's take a look at the available modes. Off removes the power from the system and also acts as a standby mode. When test is selected, 2 short pulses are emitted, which are not harmful to personnel. The test pattern appears, and brightness control may be used to adjust display brightness to the required level. Note that the selected range appears above the test annunciator in the top left. The marker annunciator in the top right indicates the interval between range markers, and antenna tilt is indicated in degrees either above or below the horizontal. The test band should be checked as complete. When the system is active, the colors indicate black, very light or no returns with rainfall rate of less than 0.7 millimeters per hour. Green, light returns with a rainfall rate of 0.7 to 4 millimeters per hour. Yellow, medium returns with a precipitation rate of 4 to 12 millimeters per hour. Red, strong returns with a precipitation rate greater than 12 millimeters per hour. Magenta indicates the presence of turbulence associated with precipitation. Weather. Selection of weather immediately places the system in a normal operating mode, requiring no warm-up period. WX appears as the operating mode. Changing the range control will change the display of weather accordingly. Turbulence. By selecting TURB on the display unit, moderate or severe turbulence can be detected within areas of precipitation and will be displayed as a magenta overlay on the normal radar weather indications up to a range of 40 nautical miles. Beyond 40 miles, normal weather radar indications will be available. Clear air turbulence cannot be detected because presence of precipitation is required. Map. Selection of map enters the ground mapping mode. The same color code as in weather is used for different return intensities. Green, low reflective returns. Yellow, medium reflective returns. Red, high reflective returns. Gain control. A gain knob is fitted, allowing for the manual control of the receiver's sensitivity in the weather, turbulence, and map modes. This enables the display's definition to be increased. The system is automatically calibrated in the detented auto position. When the gain control is not in the auto position, note how CAL appears in the top right of the display to indicate that the function is out of calibration. Below CAL, the manual gain setting is shown. Rotating the knob counterclockwise will decrease gain from MAX, indicating maximum gain, through 9 to 1, indicating relative gain, down to min, indicating minimum gain. A clockwise rotation will increase gain, vice versa. The AUX button may be used to display a checklist on the radar display as a customer option. With no checklist fitted, no aux data will display after pressing the button. Radar display on EFIS. The weather turbulence and map displays may be repeated on either EFIS navigation display by use of the black weather control knob fitted on either EFIS dimming panel. The black control knob is detented in the weather off position. Rotation clockwise increases the relative brightness of the weather display on the ND. The mode and tilt angles set on the radar display are repeated on the left of the ND. Range of the weather information on the ND can be set separately on each EFIS control panel, independent of the range selected on the radar controller. This enables 3 different weather displays in the flight deck. However, antenna tilt remains the same and can therefore only be optimized for one range setting. Before takeoff, when the use of weather radar is anticipated, the system test should be performed before leaving the gate. Only 2 short test pulses are emitted in the test mode. But be aware that radiation is constantly emitted in the weather, turbulence, and map modes, which can be very harmful to ground personnel. Always use caution when operating the weather radar on the ground. During taxi, but well away from all buildings, obstructions, and personnel, The shortest range should be selected and the antenna tilt down until ground return appears on the display. This ensures that the radar system is operational. In presence of storm activity, when lined up on the runway before takeoff, set an appropriate range for the departure track. The antenna should then be tilted from 0 degrees to plus 15 degrees and back to around 4 degrees, whilst searching for any significant weather returns. Use 1 degree or 2 degree steps and wait for at least 2 antenna sweeps after each step. Manual gain may be used to assess the relative intensity of multiple storm cells as an aid to planning avoidance of the worst areas. As manual gain is reduced, red areas become yellow, which eventually become green. The area which remains red for the longest time are the areas of greatest activity. Be sure to reset gain control to auto when weather evaluation is completed. Manual gain should not be used to locate a path to penetrate the storm area, but rather to assess which area to avoid by the greatest distance. Climb. Takeoff should be made with the tilt control set at around plus 4 degrees. During the climb out, the antenna tilt angle should be set to plus 15 degrees, then reduced until ground returns appear, before again being set to around plus 4 degrees. Cruise. During the cruise in storm conditions, the radar should be used efficiently to ensure that all weather returns ahead of and below the aircraft are detected. After reaching cruise altitude, range should be set to 40 miles and the tilt angle set to minus 10 degrees. Whilst observing for any weather returns, decrease the tilt angle until the ground returns disappear at the upper edge of the weather radar or navigation display. This ensures that any activity below the aircraft is detected. This procedure should be repeated for each range setting up to the setting appropriate for the current leg. During routine flights at cruising levels, set a tilt angle around these recommended values in order to observe the air mass along your level flight path. Mapping mode. Although the weather radar is designed for the detection of weather, it may be used for ground mapping purposes. The antenna tilt should be reduced until ground returns appear. Manual gain may then be used to aid definition. Descent and approach. During the descent and approach, the tilt control should be adjusted upwards to prevent unwanted ground returns. Here is a tabulated summary of the recommended manual tilt angles for each phase of flight. The radar system is continually tested. Any failure detected is indicated by the annunciator on the radar display. Failures are classified as soft or hard. Soft failure. A soft failure is indicated on a radar screen as one of the following: CAL, system is out of calibration, targets may appear weak. STAB, system is stabilized with respect to the aircraft, but no pitch or roll stabilization. This causes heavy rain returns on only one side of the display during maneuvering. Cool, system cooling fault allows only partial use of the system. Use only as required to analyze weather. The radar system will continue to operate with a soft failure. Hard failure. A hard failure is indicated following a serious system failure. The entire radar display is removed and replaced, for example, by RT unit failure. Other hard failures being equally indicated are ANT fault, ATT fault, IND fault, cool fault, RT unit cooling fault. If any of these warnings appear, the unit must be switched off to prevent further damage. Congratulations! You have now completed this module.